We're going to continue solving quadratics, and we're going to solve by graphing this time. So we've already practiced graphing quadratics, so the first thing we're going to do is find the vertex. Okay, so I'm going to use my equation, negative b over 2a. So here I have negative 8 over 2 times 1, so 8 over 2 is 4. So my axis of symmetry is 4, okay? 1, 2, 3, 4. So if you want, draw your axis of symmetry in, and then I know the vertex has the x coordinate of 4, and we have to find the y coordinate. So we're going to plug 4 back into the equation. So I have 4 squared minus 8 times 4 plus 12. So I get 16 minus 32 plus 12. So there I get negative 16 plus 12, which is negative 4. So this one has the equation for negative 4. So my vertex is here. I know this one is going to open up because my a is positive. So I'm just going to keep the graph going until I hit the x-axis, because what we're looking for to solve is we're looking for where does it cross the x-axis. Those are the x-intercepts, or the zeros of the graph. So my a is 1, so all I have to do is 1, 3, 5 pattern. Okay, and I just want to go until I hit the x-axis. So up 1 over 1 and up 3 over 1 on both sides. So those 2 points where it lands on the x-axis, those are the answers to the problem where it says solve by graphing. So we want to know what is x at those 2 values. So x here is positive 2 and 3, 4, 5, 6. So those are the zeros of the graph. Okay. All right, this one. So we're going to follow the same process. We're going to first find the vertex. So negative b over 2 times a. All right, so here 2 times, let's see if I can simplify that. So 2 over 1 times negative 1/4, I just multiplied straight across there. Okay, when I divide, right, it means we multiply by its reciprocal. So I flip the second one and then multiply. So it becomes a positive 4 over 2, which is just 2. So my axis of symmetry is x equals 2, and the vertex is 2 something. So we're going to draw the axis of symmetry in, plug in 2 into the equation. So I have negative 1/4 times 2 squared plus 2 plus 3. Oh yeah, I plugged in 2 for x. Okay, 2 squared is 4. A fourth of 4 is 1, and I do have that negative there, so it's going to be negative 1. Negative 1 plus 2 is positive 1, plus 3 is 4. So we got a vertex of 0.24. And this one's going to open down because of the negative a value. So now to get how much it goes down, so I'm going to do negative 1/4 times 1, 3, 5. Okay, so I'm going to put the decimals here just to help us out a little bit. So I get negative 0.25, negative 0.75, and negative 1.25. Sorry, move my math over here a little bit. Okay, and we might need more than this, so we need to go until we hit the x-axis. So down negative 1/4 and over 1. Down 3/4, so that's going to get me to the next line. Okay, down 1 1/4. Okay, so I'm not quite to the x-axis, so that means I'm going to have to keep going. So the next number in the pattern would be 7. Okay, 7 times negative 1/4 is negative 1.75. So if I go down 0.75 and then 1, that gets me to the x-axis. All right. So now our solutions are those x values where it's crossing the x-axis. So this one is at x equals negative 2, and this one is at 3, 4, 5, 6. All right. Okay, a couple more here. All right, this one, my b is actually 0 here. So I get... And whenever b is 0, you guys, the whole thing's going to be 0. So I know my vertex is going to lie somewhere on the y-axis, When I plug in 0 into this guy, I get 1. So 0, 1 is my vertex. It's going to open up. 1/3 times 135. Now this one, I am going to go ahead and graph the 135 just so I get enough points to graph my parabola, but you guys can see it's going to open up. It's not going to touch the x-axis at all. It's starting above it and it's opening up. So this one has, we're going to say, no real solutions. So we can see that right now without graphing anymore because we know it's going to open up. It can't cross the x-axis here. But let's finish graphing. So I've got up 1/3. Oh yeah, so 1/3, 1, 5/3. All right, so up 1/3 and over 1, up 1 from there and over 1, and up 1 2/3 from there. All right, so there is my graph, but we can see there is not going to be any x-intercepts. Okay, last part of this video, you guys, is finding the area of a parabolic region. And so that means a region either, we're going to say bounded by a parabola, but it will also be bounded by a horizontal line. So I'll give you an example here. So we can have something like this, and we got a horizontal line. Here, I'll just draw it in. Here's my x-axis, y-axis. Okay, so a parabolic region is something that's bound between a horizontal line and the parabola. So we're looking at what is the area of this region, okay? So the formula is 2/3 base times height. So what is the base and height? Well, base is the base of this region. So from here to here, that is the B. And then the height is how tall is that region. So vertically, how tall is it? So that is the H. Okay, so let's try that with this example. So first, it's helpful to graph these so you can count your base and height. So we're going to graph x squared minus 4. So you can graph using the axis of symmetry equation, or I'm actually just going to graph this one using transformations. This was just our parent function moved down 4. So I'm going to go 1, 2, 3, 4. And a usual up 1 over 1, then up 3 over 1, then up 5 and over 1. There we go. All right, so there is my graph. Okay, now the horizontal line is y equals 0. So y equals 0 is just the x-axis. So that is here. So we want the region that's like in between the parabola and the horizontal line. So in this one, that's going to be this region. Okay, so here's my formula. 2/3 base times height. So the base of this region is how wide it is. So from here to here, it's 1, 2, 3, 4. So our base is 4. And the height is also 4. It goes 1, 2, 3, 4 down here. So that is our height. Okay, so multiplication, the order doesn't matter. So I'm actually going to go ahead and multiply my 4's together. So I have 16. Actually, I'm just going to do all of it. So these are over 1. So we're doing 2 times 4 times 4 times 3 times 1 times 1. So here I'm going to get 32 over 3. And 3 doesn't go into 32 nicely, so let's just leave it like that. So that is our area. Area always has square units. Since we don't really know what these units are measuring by, we're just going to call it units. All right, guys, that is it for this video. Thanks for watching.